So, hello everyone. We have Matthias Heil with us today. He's a professor of applied mathematics in the School of Mathematics, but he's also the school's postgraduate director. So he'll be talking today about the master's and the PhD within the department. And I hope you enjoy the talk. We will be having a Q&A session at the end, but you can ask questions in the chat or raise your hand and unmute yourself. And thank you, Matthias, for coming today.
Good. So I think the sort of legal word of warning is we're recording this session just in case anybody wants to watch it over and over again. You know, if you're in the middle of the night, if you can't fall asleep, you can put on replay. So if anybody doesn't want to be seen, you know, it's the usual thing, just make sure you turn it off. I'm actually quite happy for people to, so what I've done is actually, it was perfect timing when whoever contacted me, because on my to-do list was to organize another PGR open day to, you know, do precisely what I'm doing at the moment. We're actually supposed to do this for everybody, for the whole world. But that got too complicated for reasons that I won't go into. So it's just a local event essentially. But what I've done essentially is I've recycled these. I've basically taken the slides that I use every time whenever I give this talk. There's a couple of things that sort of explain Manchester to people, and I will go through these more quickly because I assume you, well, I mean, I'm not sure, maybe some of you have never been to Manchester, maybe first years study abroad, you may be interested in that too, but that's the plan. It's true, I am the postgraduate director, but I'm actually only strictly speaking in charge of PhD studies. So it's, you know, we call it, what do we call it? PGR for research, PGT is taught, which is the MSc degree. So Peter Foster is the other guy who does the other half. However, we know each other well. And in fact, it turns out Peter's just given a talk last Saturday. Maybe some of you went there. And so this means he has totally up-to-date slides. So he sent me his slides, and I will basically, I didn't want to disrupt the talk. I mean, the plan really is I'll talk you through my PhD type talk. I will occasionally, I mean, I always do this. I will say a few things about MSCs at the same time, but not in great detail. And then later on, I have a couple of things where I will basically just show you Peter's slides, and of course, just ask me questions. Anything else you want me to address? So anyway you want, you can either put it in the chat. I'm unlikely to see things, you know, this hand raising thing. This is too modern for me. That doesn't work. So just put things into the chat or just open your microphone and tell me to shut up for a second so you can ask your question. Anything goes. Okay. So the setup is the usual one, just as in a lecture. I have my rear view mirror on, so I'm watching. My iPad will stay on with the camera, and I'll share the screen on the main thing. Good, share. Good, here we go. Can you see that? Yes, and I will do, let's just leave it like that. Okay, good. So it's postgraduate study, and good. So let's just start from the beginning. So here we are. So in a sense, this seems possibly like the most pointless thing to mention at all, that we're one of the largest maths departments in the UK, because you're all here already, you know this. The reason why this is actually sort of important is I don't know what you were like when you initially applied to Manchester, and you will have applied to other places too. We often get asked by parents, especially during the open days for undergraduate students, when they come here, they say, "Oh, Manchester is such a bloody big place. Isn't this terrible? Isn't this, you know, anonymous? Nobody knows anybody. It's you know, it's a huge organization. Isn't it better to go to a really tiny place where every lecturer knows every student by first name, right?" And these kind of things. And I think at the undergraduate level, which is probably what most of you are at the moment, I think it's sort of there's arguments to be made for either one, right? I mean, I think I very much hope, at least, that most of you have met people here. I mean, okay, COVID makes this a little bit more complicated, but I've always really liked big crowds. You know, there's far more people to mix with, so I think this is an advantage. At the same time, the disadvantage is it's true, it's more anonymous. That is an absolute fact. You know, you can sit in a class of 350 students and, you know, just, you know, feel intimidated by this. And it's certainly true that I don't know every one of my 350 students in the first year by name or by sight or anything really. Though a couple I do get to, you know, people who wear funky hats and things like this, I do tend to remember them. So the reason I'm mentioning this is because basically it's sort of 50-50 at undergraduate level, and, you know, you've all taken your decisions and hopefully not regretted it. When it comes to research or postgraduate, I think bigger is definitely better. And the reason really is that, you want some sort of, what I call here, the stimulating research environment. You want people to talk to. When the higher up you go, sort of go in the pecking order, the more rarefied it becomes. And the most important thing, if you're already in a small place and it's already quite, small, and then it becomes more rarefied. I mean, basically the extreme end is if there's just three PhD students in the department, who are you going to talk shop with, right? Whereas in a big place, so we have something like, I think it keeps changing, of course, something like 120 PhD students in the department. It's actually a really nice crowd. So I think personally, it's only a win, right? A big place really helps, and it's not just the social aspect of it. It's also the fact that when you're stuck with your problem, which at PhD level, which happens all the time, and in fact, I'm constantly stuck with whatever research problems I'm working on, there's people to talk to, right? I mean, we have so many staff in the department in all kinds of different areas. It's really useful for me to be able to, go next door, essentially, if we were in the building, and talk to somebody I actually really know. So in this size, this really helps to create the environment that's needed. Good. So we talk to each other, obviously, not just within Manchester, but also national and international. Then with other academic disciplines, lots of research and lots of PhD projects that have worked at the interfaces. And the list here that I'm listing is, so physics, engineering is probably sort of the two obvious ones, right? I mean, they are sort of classical numerate disciplines. They contain some people at least who appreciate the value of mathematical thinking, etc. So we collaborate with them. And then as you go further down the list, you sort of get to the more recent things. I mean, chemistry, yes, biology, medicine. I mean, this is really, these people are beginning to discover the joys of mathematics, seriously, and they're very, very keen to collaborate with us. And it's actually genuinely interesting. They're not stupid people, of course. They're all very clever, but they think in totally different ways. And they genuinely find it interesting to collaborate with mathematicians because we ask totally different questions from the questions they're asking. So that is something I mean, if you're interested in anything interdisciplinary, that's another thing where a big place will help you, because Manchester is full of academics you can talk to. And then there's plenty of industrial partners. There's a couple here. So the most exciting one for me personally was, so Cadbury's is the Cadbury's as in the chocolate. And a couple of years ago, I actually had a PhD student who's long since left, but we're still working on a paper together. In fact, the laptop is currently running a computation that came from this project. We modeled essentially, if you want the picture, it's the settling of Cadbury buttons when they're molten, and how do they spread out. So chocolate is a non-Newtonian fluid for all the fluid mechanics people in the audience, and they were interested in modeling this process, so we did. And in fact, the student was jointly supervised with close colleagues in physics, and he actually did sort of 50% maths / computation, and the other 50% was experiment. So there was a big bucket of chocolate over in the physics lab, and we attached a note to it saying, "Don't eat the experiment," because he was only going to get one bucket for his entire PhD, and he controlled himself. Good. Then the other thing that happens in a big place is there's a really big list of weekly research seminars. And that really means typically that external speakers come to Manchester and talk about their work, right? So this is stuff that is so bleeding edge that it's typically something they're working on at the moment, right? So it's often not even published. And then afterwards, in normal times, you can have a coffee with them and talk in more detail. I mean, this is, again, relatively easy to move online, modulo the coffee, of course. But there's a lot of this going on. And then it's the usual thing. I mean, you're familiar with the facilities that we have. So for instance, yes, we have a library, etc. Good. So what do we offer? This slide I put back in, but I will elaborate a bit more on MSc later on, or if you ask me specific questions. So if I count correctly, there's 6 of them in total. So there's applied. Some of them sort of have strands. You can, within the applied one, you can, but don't have to specialize into modeling or numerical analysis, or you can just do the standalone thing. There's pure maths and logic. Again, I think this exists in 2 combinations. There's statistics, maths, finance, actuarial science, and then there's a faculty level MSc in which maths is heavily involved, and that's on data science, right? So these are the MSc programs we offer. Now, the reason why I'm not saying much about them is, first of all, I don't know much about them because I'm not directly involved. I mean, I do a little bit of thesis supervision and things, but it's basically you're all undergraduate students. There's a huge element of that is similar to being taught as an undergraduate. I mean, MSc courses tend to be more specialized. That's the main difference, really. So more specialized courses, but the idea is the same. You sit in lectures, you take exams, And then finally, over the summer, you work on a research project, right? So that is probably technically one of the biggest difference to staying for the 4th year of your undergraduate degree. If you want to switch to the MMath, so if you're on it already, you will also work on a project, but that happens during term time, right? So when the exams are over, that's it, you can leave, whereas the MSc students stay on and then do their proper work over the summer, right? So historically speaking, before the MMaths was involved, MSc was, of course, I mean, MScs are useful for what they're used for, but one of the things they were traditionally used for is sort of, to train people up for PhDs. Now, not everybody who did an MSc would naturally go on to a PhD. Some would suddenly find out, no, they've actually had enough of maths and run for the hills. But, it's sort of a way to try this out. And the nice thing about the research project that you do over the summer in an MSc is that, unlike a PhD project, which I will talk about in much more detail, it doesn't have to be novel research, right? So it's just doing a very competent literature review, and so you're trying things out, demonstrating that you've understood it. It's enough for that. That won't be true for PhD level, and so in a sense, it sort of gives a bit of an option to try things out if you've never done any research before, right? And as usual, part-time options are usually available for all of these. Again, there's web pages where you can look at details. And as I said, I've got Peter's slides. And then there's these really specialized things like MSc by research and or MPhil. So they're basically research degrees, but they only run for a year, and you get a master's degree at the end rather than a PhD. But that's quite rare to do these. We've had 1 or 2 students over the years, but it's not a common thing. If you're interested, ask us. We can possibly just invent one for you. But the degrees certainly exist, right? It's just not a massive thing. Okay, so now on to the real part. I mean, that's sort of my job now. So what do we offer? PhD? So we offer a PhD, which is by definition a research degree, in all areas of mathematics. So what I've got here is the sort of traditional split of maths into pure, applied, and statistics. And the thing I should really stress, which is hopefully something you've already picked up while you studied here, is that we really operate on a, when there's some departments around the university, around the country, where they have a department for pure mathematics and a department for applied and a department for pure, and they then, for stats. And the downside with this is that they then behave like this, right? So they don't talk to each other because they're different departments. Whereas in Manchester, I hope you've picked that up. We do actually really act as one big department. And in many cases, especially when it comes to research, the subdivisions between these groups, there's lots of projects that are at the interface between them. Right, I mean, data science sort of really shines through a lot of applied and stats, but even pure. So there's a lot of overlap, and that's actually another nice thing being here in Manchester, that these boundaries are very, very fluid. It's basically, as far as administration is concerned, it's basically the group sort of act as allocating teaching responsibilities. That's where the distinction makes sense. But other than that, we're happy to talk shop with anybody who has something useful to contribute to it, right? And that is very helpful for the students too. Okay, so then what is a PhD? It's probably this sort of slightly arcane, obscure thing. The technical definition, it's a 3 to 4 year research project which leads, and now wait for it, the preparation and defense of a PhD thesis which contains an original novel piece of mathematics. Good. So at this point, panic should break out in the ranks, because I mean, you're all familiar with, we stand there, we give lectures to you, we explain things to you beautifully, and then all we're ever asking you to do is to sit in an exam in which I will simply check if you've understood what I've just taught you, right? And if you can confidently regurgitate what I've just taught you, you will get a first-class degree, right? That's how it works. And so you're learning stuff, and then you're good at passing exams or not, and that's a totally useless skill, the passing exams thing. In this case here, I mean, none of this is original, right? It's just you have to get knowledge that other people have found out before you into your brain, and then out again at the appropriate moment in time, right? That's the only skill you have there. Whereas here, really, I mean, you're beginning to do proper research. You will actually, original novel means you will do some maths and tell people about it that nobody else knew about before. Wow. And in a sense, this is sort of it's nearly schizophrenic here. It's the tension between this should be, fascinating, of course. Wouldn't that be great to do this? And it should scare the living daylights out of you, right? Because maths has been around for a long time. Lots of clever people have worked in maths. They haven't done what you've done. What chance do you have to whatever prove this theorem, do this, that, and the other. You know, that's the thing that makes it really exciting. And it takes a special kind of person. And I'm saying this to basically the entire tone of this talk is, you know, are you sure you want to do a PhD? And hopefully some of you will survive till the end, right? And you say, no, actually, I quite fancy that, right? But what I'm really trying to make sure is that a PhD is not like studying for an undergraduate degree, right? I mean, that's really something you must take away from this talk. Okay, so one of the things, and I'll have a few more slides on this now, the project is typically chosen in close consultation with the supervisor. In fact, if you ever end up applying for a PhD, because most application systems are fairly generic, what they often ask for is, you know, please upload your research proposal here. And my plea to you is please don't, because it would be ridiculous, right? I mean, how would you, I mean, you're all very clever, of course, there's no question about it. But I mean, how would you be in a position to judge what is doable as a PhD project, right? And I'll give you examples for this later on. So it's really something you want to discuss with your supervisor. I mean, we sort of know the literature, we know where the gaps are. We think there's an open problem here. And I think with a sufficiently clever PhD student, we can crack this, whatever that means, right? That's the plan, really, right? So don't feel under any pressure to come up with a project, because it'll either be hopelessly naive, you know, or vastly ambitious, or a combination of both. I don't know if that works, but you know, so just the context. Good. Then what I sometimes jokingly say is, you're ready for a PhD if you're sick and tired of lectures and exams. And that is sadly, that's a necessary, not a sufficient condition for doing a PhD. But there's an element of this. I mean, you certainly shouldn't do it because you like hanging around universities and you don't mind taking exams or even like them. Nevertheless, there are still some specialist lectures, even at the PhD level, make you take 100 hours. Is what is known of specialist lectures, right? But there's a huge catalog you can choose from. And then there's, as I said, research conferences, seminars, etc., that you initially attend and listen to, and then ultimately, you're supposed to go out there and tell people what you found and tell them about it and get them excited, right? So that's sort of part of the thing. So good. So here's the big thing: how does research actually work, right? I mean, you're familiar with the taught and teach and examine way of doing math. So research is different, right? So apologies, this is really dumbed down, but I quite like it. So it's the 3-stage introduction to how research works, right? Step number 1, identify a suitable research project. Good. So what that could be, here's a couple. You could prove the Riemann hypothesis. You could prove the existence of smooth solution to the Navier-Stokes equations. And there's a couple of others, right? So I'm not sure if you've spotted where these were taken from. It's the viscous fluids. People may recognize the second one here. There's the Clay Institute. These are Millennium Prize things. So when I mean, don't know where you guys even born, when the Millennium came around. But anyway, you were little and probably weren't aware of this at the time. At the Millennium, there's this institute in the States, and they offered $1 million thing, yeah, dollars obviously, for any mathematician who solves these problems, right? So they sort of sat down with some boffins, and they decided these are the big unsolved problems in mathematics, right? Really, somebody ought to pull their finger out and solve these, right? And as a little carrot, apart from fame, you get $1 million for this, right? So as far as suitable research project is concerned, this is okay, right? If you do any of these, you get your PhD for free. You know, you'll be immediately famous, and you get $1 million and whatnot. So it's fine. PhD is not a problem. The trouble is, how realistic is this? And that's the balance, really, right? I mean, lots of really clever people have tried and failed so far. So this would not be a good PhD project, right? So it has to be not just worthwhile, you know, tick, 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 but it's the doability that, of course, you never quite know. But the ones I've just listed are probably on the wrong side of ambitious, right? So be careful with that. So this is basically where your supervisor comes in. We hopefully have a feeling for what is interesting, certainly to us. And we hopefully also have a feeling for what has been done before. But, you know, you have to be careful, always double check this. And you know, then you iterate on this project with the student. Good. So then once you found the project, you establish the current state of the art. And that sort of follows on from this, you know. Your supervisor will have told you things like saying, you know, this is a really interesting problem. Nobody's done this. I'm aware of this, that, and the other, but they sort of, you know, they haven't really fully cracked it. Be careful, right? I mean, you want to do your own literature research, right? I mean, the most embarrassing thing would be that you sat there for 4 years and you did some heavy computation to do something, and then it turns out when you're submitting your thesis that the examiner say, yeah, but Euler did this on the back of an envelope in, I don't know, 1751. That must not happen, right? It has to be novel. So be careful, you know, read around. And it's true, sometimes you sort of, you know, you find pockets of literature that you know, people just weren't aware of. But it's basically, this is less of a problem, but just be really, really careful. Just because your supervisor says, and this really does happen, that I sort of say, well, I don't think that's been done. I wouldn't know where to look. And then, next week my PhD student comes back and says, well, actually, here's the paper. They've done it. It's very elegant, much more elegant than what you suggested, and that's fine. Okay, so that's the state of the art. So to some extent, it's read, read, read. If you're doing a computational project, you may sit down, write some code, try things out. And the real thing is you have to find out where the current state of affairs is, right? Because you don't want to reinvent the wheel. And then finally, you advance the field, right? That's the novel bit. You do something novel beyond what is known to mankind. So basically, it now ties together, right? You understand why and how previous work has failed and where the limitations are. And based on that, you try a different approach, right? So initially, a supervisor will have a few things. The starting point for most projects tends to be, in my mind, I always say, if I didn't have to teach undergraduates and give talks to potential PhD students and all this, if I had a bit more time in my life, then these are the next couple of things I would do, and it would probably take me a month of concentrated work to make some progress with this. But if you give me a PhD student, I can probably train up the PhD student to do it in the first year, right? That's sort of the rough idea, right? So we point in different directions, saying, I have this idea, I think this should work, try it out, right? That's what I mean by try different approaches. And then, of course, what happens is that doesn't work either, right? But so that is immensely frustrating, right? And being frustrated and banging your head against the wall is a really important part of a PhD project. You must nearly enjoy that aspect of it because it happens so often. It still happens to me every day. I try think of something really, really clever, and then I spend a week on trying to actually figure it out, and then I realize this is obviously stupid. It doesn't work. But what makes this worthwhile, apart from enjoying the pain, is that you understand why this has failed, right? And that sort of changes your perspective of the problem. So that then suggests another approach, right? So you try this and you go away for 2 or 3 weeks and try it, and then you understand why that fails. And then you think, oh, damn it, this is really frustrating, but maybe we should try that. Right, and so the first time I gave this talk, one of our existing PhD students sat at the back. Don't actually know why he was there. He was sort of interested what I was going to tell the potential new students, and he said this part was way too short. This is now going to end, of course, but he said, this. So really, don't underestimate this. This is to a large extent how research works, right? I mean, it's not total random walk, but you will work really, really hard, and because these problems are hard, of course, right? And then in many cases, it turns out it doesn't work, but you learn something new from this, right? So the same thing happens again. Now, what makes this still attractive to some extent is that you increase the understanding of what's going on, right? And that is sort of, as you're understanding why certain approaches don't work, it actually makes the structure of the underlying problem much, much clearer, right? And it is often actually, so I mean, in fact, I won't mention any names, but a PhD student of mine who's just graduated, actually, we're still writing a paper on this together. Basically, what we initially tried turned out not to work. But boy, was it interesting why it didn't work. I mean, the examiners, when they examined this, they absolutely loved it, right? They didn't care, so basically the approach was something numerical. We had an idea how we could make a method much better. And then he spent his entire time, working on this. In certain cases it worked, in other cases it didn't work. And trying to find out why it didn't work. So, I mean, this is really, it's exactly that story here, right? But it was a beautiful mathematical story, right? So on the one hand, you can say it's really disappointing because he has not actually come up with a faster method for solving this particular problem. But we've learned some fascinating mathematics from it, right? And that is also, that is good enough for a PhD, right? Of course, it's even better if it also works. But, this is the nature of research, right? Good. And then, finally, at some point, you crack the problem. And, as I said, what that actually means really depends. You often adjust the scope of the project as you go along. Okay, so I mean, really, take-home message is doing research is not at all like studying for an undergraduate degree, and it's something completely different. And this sort of, the nervous tension that I've hopefully got across here, that is something that should appeal to you, right? It's sort of nerve-wracking, but in a good way, hopefully. Good. And then, again, relax. You're not thrown in there all by yourself. Your supervisor will obviously provide guidance, but ultimately, you should become the expert in this. I mean, there's nothing better, honestly, than, whatever you meet your PhD students, sort of point them in the right direction. At the end of the meeting, give them a little to-do list, maybe not verbatim, but in spirit, you say, okay, if I need to try this, and then we'll meet again next Monday. And the best thing really is when the student sort of takes the initiative, right, and suggests these things themselves. You know, alternatively, I suggest something and the student has already thought it through and saying, yeah, that's a nice idea, but it doesn't work. Look, I mean, that's when you can see how people grow up. It's one of the most satisfying things ever, really, right? Good. And so details are really subject and problem specific. So talk to people, you know, potential supervisors, course directors, etc. I mean, this is the general stuff that I just told you. Good. So if that hasn't put you off, you may, I mean, so this basically, if you like this kind of thing that I've just described, that will take care of 3.5 to 4 years. And then the question still is, what do you do with this afterwards? You know, you can't stay a student forever. Sorry. At some point, you have to go out there and face the real world. So this, again, I put a bit of master's degree in there. Again, so master's course is basically you learn more mathematics. That is intrinsically a good thing, honest. Now, this is a slightly subtle one. Where's that word? Now, okay, I would actually like to tone this down. I've copied the wrong version of this. So you acquire specialist knowledge, fact, and what I'm blatantly declaring here is that makes you more attractive. Okay, it's okay to many employers. So note that I'm not saying that automatically makes you attractive to all employers. Right, so be really careful about this, because in this country, so you probably know either from my accent or because I've admitted to being German before. In this country, there's this concept that doesn't exist in Germany. The concept is known as being overqualified. I mean, in Germany, it's Vorsprung durch Technik, right? So, I mean, this isn't quite true, but I mean, generally speaking, I was really confused by this concept. There are many employers in this country. It's just a different way of operating. And I'm honestly not defending one against the other. The idea is basically, you know, you learn some useful stuff at the university and then they train you on the job, right? And if you basically come out as a useful member of society and you've learned some special tricks at university, that's okay. There's actually no financial benefit from them if you spend another 4 years at the university, you know, becoming even more specialized in your PhD. You know, why would they want to pay for that expertise if they have no need for it, right? I mean, having said this, there's plenty of employers out there who value having PhDs, you know, MSc students, you know, graduated MSc students out there. But please don't, I mean, certainly don't do a PhD because you take it for granted that it will get you a better job, right? That is not why you want to do a PhD ever, right? You want to do a PhD because you love doing the PhD. And then when you do this, you may get a job at the end. But one doesn't follow from the other, right? MSc is sort of slightly different because it is much more specialized. You know, we sometimes get people sent by their employers to do an MSc to acquire some specialist skills, right? And then here's this one thing that is sort of historically certainly true, that the research component in an MSc or the project over the summer sort of allows you to try out research in a slightly more sheltered environment. And the same would be true for your 4th year maths project, right? You can, if that goes well, you can start to do some research, but you don't have to, right? It doesn't have to be novel, but you sort of get a feeling for how this stuff works. Okay, so in PhD, same applies. You learn a lot more mathematics, though possibly narrower. Again, same thing about the employers. But I mean, this is really, you know, that's why you want to do a PhD. You have the unique opportunity to immerse yourself in a particular subject area and advance to the leading edge of what is known in that field. Ha! I mean, that is a fantastically pompous sentence, but it is true. You know, if you don't get this, then don't do a PhD. That must sort of intrinsically appeal to you, and everything else is sort of a side benefit. In fact, there's only one profession where having a PhD is absolutely essential, and that's if you want to be one of us. Not sure if that's a desirable thing or not, but if you want to be an academic, then of course, at some point in your life, then you have to have a PhD. But in most other places, you can sort of work your way through the ranks as well. Okay, admission requirements is, you know, if I haven't put you off, what do we expect? And this is basically true for MScs as well. So we expect you have typically a good upper second class undergraduate degree or in other numerate disciplines, right? I mean, the bottom line is because things do get more and more specialized as you rise through the hierarchy. It doesn't, you know, the thing is, as I said, if somebody comes along with a first-class degree from a respectable university and you look at the transcript and it turns out they've scored 105 out of 100 in every single one of their exams, then I'm personally actually nearly a bit nervous. Because, you know, what this definitely shows me is that student is very, 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 very good at taking exams, possibly insanely so. Because I mean, taking exams is so different from anything that is useful for anything, really. I mean, yes, it sort of checks that you've understood stuff, but you know, how about just getting 80 out of 100 to prove this, right? What we really want, certainly for a PhD, is that first of all, I mean, you have to have what it takes. You know, you have to have the subject knowledge, and you have to be motivated to do the research that I've just described, right? And that does not involve primarily being able to pass exams, right? So one of my best, in fact, my first and amongst the best ever PhD students I have was a maths and physics student who, you know, had a 2-1 degree. That's basically because he could have done a lot better if he had felt like it. He just hated exams, but he really had what it took, right? I mean, it was fantastic. And the other things, you know, we do at an undergraduate level, certainly in a big place like Manchester, you know the deal. Basically, you apply. We tell you if you get these grades, then you're in, right? It's as easy as that. And then we sort of think, you know, statistically, you'll probably have what it takes to come out at the other end with a degree. At PhD level, you will spend a lot of time discussing things with the potential supervisor. You really want to try each other out, right? I mean, so the open day, which this sort of replaces, we usually have on the atrium bridge, and you know, you can then mingle with people and talk to PhD students, supervisors, etc., to find out what it's really like. Right, that it becomes really important. So it's not so black and white saying, you know, you must have an average of 88.5, and if you only have 88.4, then you're not doing your PhD with us. Honestly, that doesn't matter at all, right? At the same time, if you're sort of scraping a pass degree, then you're probably not very good at maths, and we probably wouldn't want you for that reason, right? But anyway, in between, talk to us, right? Indeed, talk to us. There it is, the next bullet point anticipated. So what is really non-negotiable is you must love mathematics, because that's what you do. I don't know what I mean by love or by must, but you must, right? So that's really what you should check. Okay, a final thing, if you, I mean, this is sort of the, or the airy fairy thing, you know, the intellectual stimulation and all this, but there's also the hard truth of money. So here we go. So the can I remind you of these sad facts? When you study for a degree in this country, you need to pay the fees, and there are different fees. Oh, look, EU, I meant to update this. No more. You're either a Brit or you're not, or you're allowed to stay. But anyway, it's now just UK and overseas. I think actually there may be a grace period or something, but you know, this is there are different rates for certainly for overseas students. And then you also probably want to eat something while you're here, so you need money for all of these things. That's just the way it works. Good. So yes, you can fund yourself, but please, unless you've got an oil well in your garden, you know, otherwise independently wealthy through, I don't know, bank robbery or whatever it took to get this money, then please don't fund yourself. I mean, certainly what I mean by this is, if you have the idea that, well, I can sort of work in the pub in the evening and that can pay for my PhD, no. A PhD is a full-time job. It really is, right? So you cannot run a part-time job in parallel this to fund this. So don't, right? I mean, if you find a grant from somewhere, or if you have a rich aunt or whatever, or uncle, it doesn't really matter. If you can do it, then of course consider it. But please do not assume that you can just sort of work on the side to pay for all these things. It's you shouldn't. Okay, so this is, I mean, it's also fund yourself possibly for a master's degree if you're confident that this is needed as a stepping stone to a more specialized job, then absolutely, then it's an investment. But please not for a PhD. I will not let you in. Your employer may pay for it, less likely for a PhD, but I'll come to this in a second. There's other options. So there's career development loans. Again, this mainly applies to MSCs. But then finally we get you can still get a grant, and in fact things get easier when you come to PhD level. So I have separate slides, the ones that Peter Foster has given me on MSCs. I will only discuss PhD here. So the traditional sources of funding are the following. EPSC is the Engineering and Physical Sciences Research Council. So it's basically taxpayers' money, right? And they offer studentships for 3.5 or 4 years. Competition is, yeah, fierce. It's competitive, of course. We know we don't give away this money, but it's, if you over the past years, I have to say, I've done this job for a long time. I've sat through many funding meetings. And my impression has actually always been that if somebody's good enough, we'll find money for you. Now, that is a fantastically useless statement to make, because, you know, you're sitting there thinking, how do I know if I'm good enough? So anyway, as far as you're concerned, it's just competitive, right? That's just what it is. But I've basically, you know, with my PGR director's hat on, I've been able to hire all the students I wanted to hire for the department. which is, and you really don't want to hire any weak students because you're not doing anybody any favor with this. I'm sure we get these judgments wrong sometimes, but there is money there, right? The department also has a pot of money. That shows you how much we love PhD students. This is money that we could use to buy more chocolate biscuits or hire more lecturers to lessen our teaching load or marking load. And no, we don't do any of these things, but we pay PhD students from this, right? So they're basically financially, they're exactly the same as the EPSRC ones, because we want more PhD students around. We realized that EPSRC don't give us enough money. That's our own money that we dig into, right? So that's financially equivalent. And then there's a couple of other external partners that we collaborate with. So Heilbronn is sort of, it's GCHQ essentially. There's a doctoral partnership there specifically after pure maths, probability, data science, quantum information, and all this. And it's a really attractive scheme with internships at GCHQ and whatnot. We have this Manchester Mathematical Modeling in Science and Industry, MMSI, which I wish they had a shorter acronym for it. They are specifically PhD projects that are in collaboration with other people around the university, right? So this comes through money from faculty at the moment, because they want to encourage collaborations between mathematicians and other academics in Manchester. And there will be calls for projects very soon, so I will tell you where this appears. And then there's extra money. The dean and the president, also make money available at certain points in the year. And then finally, there's loyalty bursaries, which I'll come back to at the very end, for existing students, which is you essentially. Okay, and then finally, there's research grants, which basically means, an academic goes to the research council and say, I have this fantastic project. Please give me some money to work on this. And then if the research council is convinced that that is true, they give that person money. And then sometimes that money may include studentships, right? So that's then for very specific projects. All the other funding is basically general purpose, right? We can give this money to work on any project you want, provided it's academically strong enough, of course. So here's a couple of projects. I'm 100% sure about the last two. So Bill Lionheart has a project with DSTL. So that's sort of an industrial collaboration. And it's a case studentship, which means it's part paid by DSTL. And it comes with a top up from industry, right? So you get paid even more than you already get paid as a PhD student. So that makes it even more attractive. But again, it's the project should attract you. Alice is looking for a student on control-based exploration of disordered systems. Here's the email address if you want to find out. Now, Ian Hall he's the head of the stats group, and he's sort of got a joint appointment with Public Health England. So guess what he's doing at the moment? He's on many of these COVID committees and whatnot. So this is actually, I haven't double checked with him because he doesn't reply to my emails anymore. He's too busy. This is the project he had last time. He's in touch with lots and lots of these people. And if you're interested in stats projects in this sort of public health area, then he's your man, right? If you can get hold of him. So it may not be up to date, but anyway, if you're interested in the kind of stuff that he does, if you want to get involved in COVID modeling, then talk to him. He probably has some money and space to do that. And this is sort of ongoing. Other grant applications are always pending. Okay, so web pages. I'm sure you're familiar with the concept of Google. So if you put postgraduate funding in Manchester in there, it'll probably find you something. This is, in fact, I say here, here's a limited list of useful web pages. So actually, for the first time in a long time, I've checked which of these many links to work, and that was the only one. And I haven't changed the sentence above. So anyway, this works. There's a couple of funding opportunities. They're good. So anyway, general advice. As far as paying the bills is concerned, it's sort of a really, so keep in mind, the main thing why you want to do a PhD is the intellectual stimulation, right? Big word, but it's the only way to describe it. Nevertheless, you then have to be pragmatic. How do you pay the bills, right? So what should you do? Get good grades. Despite what I said, nobody will hold a first-class degree against you, right? We just want to make sure you have more than that. It's not all you have, right? So get good grades, absolutely. Talk to potential supervisors to discuss possible projects, because often projects are sort of, certainly for anybody who works with me, we sort of make up projects on the fly, really, something that suits the students' interests, suits my interests, it suits our joint expertise, etc. So talk to people, right? And as I said, this is not like just applying for a place on undergraduate program. It's much more subtle than that. You know, I mean, you're going to spend 4 years with this guy or girl. So make sure you can stand each other's sense of humor, for instance. You know, it's these kind of little things that can grate after a while, right? Good. So then apply early, but not too early. And now is no longer too early. In fact, it's nearly a bit too late, but it's not actually. We have money. So what I mean by this is, don't rush this step here, right? I mean, certainly you probably want to this, certainly as Manchester students, if you want to study in Manchester, then there's absolutely no excuse for not talking to people about potential projects before you even apply, right? Basically, when it comes to filling in the electronic application, you should be able to say, I've already spoken to Professor Boffin, and we want to work on this project. And then, you know, Professor Boffin just confirms this, you get an academic offer letter, and you get considered for funding, right? And so don't apply too early. I mean, there's some people who send us an application in September of the previous year and say, I want to do a PhD in applied maths, or sometimes they just say, I want to do a PhD. And then we sort of think, well, you know, can you be a bit more specific? You know, what exactly are you interested in, right? So just save us that time and do your homework, right? Good. And then most importantly, get meaningful references. I mean, this really cannot be understated. We do want to find out, you know, with any degree in the UK, we want to make sure that when we admit you to any academic program, we want to be confident that you will emerge with a degree at the end. Now, that doesn't work for everybody. Sometimes people drop out for all kinds of reasons, because we got it wrong, they changed their mind, whatever. But, you know, we have to be confident about this. Now, the trouble with PhDs is that you do so little research in this country as an undergraduate student, right? So give us a chance, you know, trying to find referees who can meaningfully comment on your ability to do research, you know, or their anticipated ability, your anticipated ability to do research. The people who have supervised your final year projects, summer research internships, if you've done any. Failing all this, you know, at least academics who've noticed you in the lectures, in the lectures, because you've interacted with them, asked good questions, this, that, and the other, right? I mean, really, people, the worst reference you can get is from a student who looks quite strong on paper as far as the grades is concerned. And then you get 3 references where the referees basically say, yeah, that it's a good student, and then they just list the grades, right? So they're basically saying, look, it's a good student, and I base this on the fact that he's got the following grades. Well, I know this already, you know, I want something more when I want to assess this. So, but in sometimes you can't do this anymore because the people just don't know you any better, right? So try to find somebody who can comment on your research ability. And then, as I said, talk to supervisors directly if at all possible. Good. How do I find out more? Ta-da, mark shot. So that's me. So it's basically what I can do at the end. I can give to the organizers, the Math Society. I can give you these slides. So don't try to scribble down the email addresses. You can have these slides. So that's me. I'm sort of the big boss of anything PGR. Stefan Güttel looks after specifically after the applied and numerical analysis one. So he sort of sits in between. He looks, I mean, one of his roles within PhD admissions is he basically looks at all the applications in applied and decides, is the student good enough, is the project good enough, right? It's not just up to the supervisor to decide this. He does the quality control. And then he also decides who to put forward for potential funding at the departmental level funding meetings, right? So there's 3 of these people, and they all put their best people forward, and then we decide, you know, collectively who to fund the next round. So that's Stefan, that's Peter Simons, there's Pure, that's Corbin and Strimmer, who looks after all the rest, which is a lot. Good, and then here we are. So the questions, let's just have a quick look. The question that apparently arose is the discussion MSc versus Maths, and then also MSc funding. So if there's interest in this, I can then afterwards dig out Peter Foster's slides. And okay, all the other stuff is cancelled, obviously, because it's a bloody virus going around. Okay, so I'll stop here. And just to let you know, I'm happy to elaborate on, I mean, if you're in your 3rd year or earlier, and you wonder, you sort of think, I want to stay for an extra year, should I do an MSc or a Maths, and what does Professor Heil think about this? Then I'm willing to tell you what he thinks. And then MSc funding, I have specific slides that I can dig out, but I think I'll stop here to give you a chance to ask some questions. So I'll stop sharing for now.